11.4 Active versus passive immunity. Active immunity results from natural exposure or forced immunization. However, it is an individual immune response. We have either been exposed to some pathogen naturally, or we have been injected with a portion of some pathogen, so we have been through our own immune response. As a result of that immune response, there will be antibody produced, and that antibody can be measured in blood plasma. Here is a list of a number of things for which we typically receive vaccinations: hepatitis, tetanus, diphtheria, Haemophilus, polio, a number of these. And so what happens is we are injected with either a weakened virus or just a portion of a virus or a weakened bacteria, and our immune system goes through that natural individual response. We produce antibodies, but we also produce those memory B cells. And so if we have subsequent exposure, then we can have a very strong, very immediate response. This diagram illustrates how either natural exposure or vaccination results in the first versus the second response. In this diagram, we have time across the bottom in days, and then on the y-axis we have the antibody concentration in blood plasma. And so beginning on day 0, we have some exposure. So this could be natural exposure or it could be a vaccination. And you see a very slow increase in antibody production. And so it takes several days before there are appreciable amounts of antibody produced. Those B cells have to go through their activation process, their clonal expansion, then the plasma cells begin to secrete antibody. And so this takes some time. However, if we have a second exposure, again, this could be natural exposure or this could be a booster vaccine. Many times we get vaccines for the same pathogen several times, because with each subsequent exposure we get a more massive immune response. So on day 60 we have a second exposure. Look at the slope of that line. Antibody concentration goes up very, very quickly. This is because of the presence of those memory B cells. Each of those can be activated, go through their own clonal expansion very rapidly, and so within just a few days we have very large concentrations of antibody. Passive immunity is when we receive antibodies that were produced by someone else. So we're not going through our own individual immune response. There are some antibodies that are secreted in milk, so infants can get some immunity through milk. We can also get globulin injections, which are injections of antibody. So if we are ill and we get something like a globulin injection, the response is going to be very, very rapid because we're not having to go through our own B cell activation and clonal expansion. However, there are also no memory B cells produced, and so we will not have subsequent immunity as a result of passive immunity. There are a number of situations where we have an inappropriate immune response. A delayed allergic reaction involves memory T cells. An example of this is poison ivy. There is an oil in poison ivy plants that can penetrate layers of the epidermis and bind to plasma membranes of some of our own cells, and then memory cells recognize that as a pathogen and will attack. What you're probably more familiar with would be an immediate allergic response or a hypersensitivity response, often called hay fever. This is where the body will mistake some relatively harmless particle, it could be ragweed pollen or Johnson grass pollen or pet hair, relatively harmless, but the immune system recognizes that as a dangerous pathogen and in some cases can have just an overwhelming response. This involves a specific antibody called an IgE and release of the chemical histamine, which causes the inflammation response. We would take an antihistamine when we're having allergies to block the action of the histamine. There are some other inappropriate responses where the immune system attacks our own body. These are autoimmune disorders. So again, it is mistaken identity, but in this case, it is our own body, our own cells and tissues which fall under attack. Some examples of autoimmune disorders: rheumatoid arthritis, diabetes, multiple sclerosis. There are a number of situations where our immune system can mistakenly attack our own body.